In this video, we'll be talking about how to name alkanes. In naming a structure like this, we must first know our point right here. Each point right here represents a carbon. So in naming something like this, we must first count how many carbons are in the structure or in the main chain. We have 6 carbon in our structure, and 6 carbon right here represents a hexane. So the structure's name in here is hexane. Just a reminder for you, 1 carbon is methane, 2 is ethane, 3 is propane, 4 is butane, 5 carbons here represents a pentane, 6 would be hexane, 7 would be heptane, 8 carbons would be octane, 9 would be nonane, and 10 would be decane. So it is advisable that you would memorize all these names regarding alkenes. Let us try these examples. Let's start with the first one. First, count how many carbons are in there in the main chain. So this would be 1, 2, 3, and 4 carbons. 4 carbons represents a butane. So this would be a butane structure. Second one would be this. Count how many carbons again. It would be 1, 2, 3, 4, 5, 6. There are 6 carbons, which represents a hexane. Third one would be this. There are 3 carbons in here. 3 carbons is propane. And for this last one, there would be 8 carbons in the structure. 8 carbons is an octane. Let us try this example now. Whenever you encounter something like this now, it would be best to locate what is the main branch or the main chain of carbons first. It means what is the Let us try this example now. Whenever we encounter a problem like this now, it would be best to first locate what is the parent chain. The parent chain here has the longest continuous chain of carbon atoms, such as this one now. It acts as our parent chain. So, should we count it this way? Or should we count it this way? This is where a substituent comes into play right here now. A substituent acts as a branch from the main parent chain, but is not part of it. What we would want here would be the lowest number of a substituent now. So this would be the correct counting, since 2 here is less than 4. And now, how can we name this substituent? Let me just explain it to you in this format. If we are going to rewrite this would be something like this. This represents the first carbon, this represents the second carbon, and its substituent right here. This just represents a bond, and remember, it always has the carbon in there. So this should be CH3. This is the third carbon, fourth carbon, and fifth carbon. Now our substituent here has only one carbon atom, which has the name of methane. But since this is a substituent, it would be called an alkyl group. An alkyl group is an alkane that basically sacrifice one hydrogen carbon in order to bond with other. Know that methane corresponds to CH4, but since what we have here, it would be CH3. It is an alkyl group. Since this is a substituent, just replace A and E with YL. So this would be a methyl. It is just a methyl group now. So by that, this is a methyl. And how can we name this now? First would be to locate which carbon the substituent is in. It would be on the second carbon. So this would be 2-methyl. Whenever we are naming carbons, we must separate the number from the letter by a hyphen. Now that we have our name substituent, let us now get the parent name. We have 5 carbons here. 5 carbon. 5 carbon would be equal to pentane. So just add pentane right here. And so this would be your final name for this structure. Let us try this other example now. First up again, locate what is the main or the parent branch right here. It would be this one since it is the longest chain. Now how can we count it? Should it be this way? Or should it be the other way around? The correct answer would be this way. Again, because our substituent is in right here and it has the number 2. Or it is positioned in the number 2 carbon, which is the lowest one. Now that we have this, we must first see what is our substituent. We have 2 carbons as our substituent. 2 carbons corresponds to ethane. But since it is a substituent, it is an alkyl group again. Replace ane with il. So this would be ethyl. The position of our ethyl is in the second carbon. So this would be 2-ethyl. And now that we had named our substituent, let us name our parent chain. We have 6 carbon on our parent chain, corresponds to hexane. So it would be 2-ethyl hexane as our structure. We have right here our problem now. First again, locate what is the main branch. It would be this one again. So our counting right here would be obviously now right to left because our substituent is in here. So if we were going to count it, it would be like this. Our substituent only has 1 carbon, which corresponds to methyl. And it is in the second carbon position. So this would be 2-methyl. And our parent chain has 5 carbons, which corresponds to pentane. If you're going to count it left to right, it would be 4-methylpentane, which is wrong because once again, you would need the substituent to be on the lowest number possible. What would be the structure of this? Once again, find what is the main chain or the parent chain. It would be this one. And assign the numbers. Let us count it right to left. And now, identify our substituent. These are both substituent. They both have only one carbon atom, which represents a methyl group. Since they both are methyl, just put it as dimethyl. If in case you have 3 identical methyls, it would be trimethyl. Just remember that. And they are both positioned at 2 and 3rd carbon. So this would be 2, 3 dash dimethyl. This would be your substituent name now. And your parent name has 5 carbon, which is pentane. So the name of this structure would be 2, 3 dash dimethyl pentane. What about this one? Our parent chain again is this one. And it does not matter whether we would count it this way or the other way around, because you see our substituent all ends at the 4th carbon position. Our substituent right here now is 2 methyl groups because they both have 1 carbon, which represents a methyl. Since they are both methyl, let us name it dimethyl. And they are both positioned at the same carbon. So this would be 4, 4. Don't just put 1, 4. Put all the position and put the hyphen. Now that this is our substituent name, let us now add our parent name. Our parent name right here has 7 carbon, which is pentane. Wait, I mean it is heptane. So the name of this structure would be 4, 4 dash dimethyl heptane. Trying this one. First, locate what is the parent chain. It would be obviously this one. Let us count it. If we're going to count it left to right, our lowest carbon number, which has the substituent, would be at the 3rd. If we're going to count it right to left, it would be on the 4th carbon position. So it would be, the correct one would be left to right. And now, let us name our substituent. Our substituent here has 2 carbon atoms, which corresponds to ethyl. So this would be the name substituent in here. For the 4th carbon, it has 3 carbon atoms. 3 carbon atoms corresponds to propyl. For the 5th carbon atom, it also has 3. For the 5th carbon atom that has the substituent, it has 3 carbon atom, which corresponds to propyl once again. Now, when naming this, it would be best first to do this in alphabet. Now, in naming this, it would be on the alphabetical order. E comes before P. So it would be 3-ethyl. And since it both has propyl, this would be dash 4, 5 dash dipropyl. And our main carbon chain has 8 carbon, which corresponds to octane. So the name of this structure would be 3-ethyl dash 4, 5 dash dipropyl octane. But if you want it in the skeletal form, first put 8 carbon chain. So this would be the 8 carbon chain. And on carbon 3, we have an ethyl, 2 carbons. For the fourth one, it has propyl, 3 carbon. And on the fifth one, 3 carbon again. Remember, every point here represents a carbon. So the skeletal structure would look like something like that. Let us try this next example now. First, let us locate the main branch. If we're going to count it something like this, we have 7 carbon atoms. But if you can see, there are also something like this when you're doing it. It also has 7 carbon atoms. So what would you do if you encounter something like this? Whenever you encounter something like that, you must choose the main carbon chain which has the most substituent available to you. So if we are going to do it this way, if this would be our main parent chain, we have 3 carbon that are we have 3 substituent that are bonded to our main chain. But if we are going to count it in this way, we have 4 substituent that are bonded in our main chain. And thus, this would be our main chain right here. And our counting would be also something like this because our first substituent is on carbon number 2. And now that we have that, let us now name every substituent, starting with the second carbon atom that has substituent. It only has 1 carbon atom, which is methyl. The one that is located at carbon number 3, it also only has 1 carbon, which is methyl. On the fourth carbon, it has 3 carbon atoms, which would be propyl. And for the fifth position of the carbon, it is also a methyl. Now that we had named our substituent, let us now arrange it in alphabetical order. M here comes first before P, so it would be methyl. But we have 3 methyl here, so it would be trimethyl. But first, let us put all the position. So this would be 2, 3, 5 dash trimethyl, since they are 3 methyl, and put a dash 4 dash propyl. And our main parent chain has 7 carbon atoms, which is heptane. So this would be your name structure.